Hello again. Previously we talked about the graphs of exponential growth and decay functions. Well, today we're going to kind of do a little bit of an extension of that, and we're going to talk about two little formulas for exponential growth and decay. And the first one we're going to talk about is this one called exponential growth. Okay, the exponential growth formula looks something like this: A times 1 plus r to the t power. Okay, it's a little equation that can be used to find the value of an exponential function. Okay, and each one of these things has a different part. Okay, the y here is the ending amount. A is your starting amount. Okay. T, as you probably know, is time. And the tricky one, even though it's not that tricky, is the R. R stands for the rate. Okay, and the rate is the percent. The things we're going to look at today are things increasing by 20%, things increasing by 4%. Okay, how much it's growing exponentially. And one thing you probably are aware of, but whenever you have a percent in a formula or an equation, it needs to be changed into a different form. And we always change a percent into a decimal form. Okay, so another thing maybe to make note of here is that percent has to be in the form of a decimal. Now here's a real quick, an aside here real quick. How do you change a percent into a decimal? Well, what we do is we move the decimal point over 2 places to the left. It's 2 places to the left. 5%, 1, 2, it's 0.05. Okay, kind of like we did with scientific notation. Move that decimal, do those little bubbles, and fill it in with zeros. Okay, 4.3%, one more, it's moved over 2 times, 0.043. Okay, a common mistake I see people make is they just bump it over in front of the 5, in front of the 4, but it has to go 2 places. Okay, so there's kind of the different parts of this exponential growth model. Okay, this page is in your book. If you want to make reference to it, it might be a little clearer, a little bit neater. But yeah, so you can certainly look there for another spot. Okay, here's an example of one. Okay, these are going to kind of primarily be used with little word problems. Okay, but they're talking about the prize of a radio station. It begins with a $100 gift card. Okay, and once a day, a name is picked. Maybe you've heard this on the radio before. The person has 15 minutes to call in the prize, and if they don't claim it, it goes up by 2.5% the next day. So the pot increases. Okay, they want us to write an equation to represent the amount of dollars after T days. Okay, so that means our answer is going to have a T in it. Okay, and here's our little exponential growth model. Okay, you can see the original amount was $100. Look at the percent, 0.25. If I move it 2 places, it's 0.025. And you don't necessarily have to add those together, but they did to get 1.025. And notice how that stays as a T. Okay? So this would be my answer for the first part of it. It is going to have a T in it. Okay? And the last part down here says, how much will it be worth in 10 days? Well, what they did is then we're going to take the 10, and the 10 gets plugged in for T. Okay? Now, I know it's a pretty straightforward, but if we type that in the calculator, okay, way up at the top up here, if I take my 100 times 1 plus 0.025, all raised to the 10th power. Okay? So after 10 days, instead of $100, it'd be $128.01 if we round it to the nearest penny. 128.01. Okay? And that would be my answer. Okay, with this money stuff, don't forget to go 2 decimal places. Okay, that's the exponential growth model. Okay, we're going to try it one more time right here. Okay, and I'm going to just rewrite that equation so I have it for future reference here. We're going to add a couple of them up here today. Okay, so exponential growth was y equals a times 1 plus r to the t power. There's our exponential growth one. Okay, well, let's talk about this. The population of BHS was 1450, and it increases by 2.5% a year. Can we write an equation that has that I could use to find the population of BHS in any year after t years? Well, it's going to look like this. The original amount, the A is the original amount, 1450, times 1 plus, because it's increasing. Okay, so we're going to add on 2.5%, but just like on the last one, I have to move it 2 places to the left to get 0.025. And again, it's going to be raised to the t power. Okay? If I want to know the population in 2020, let's suppose this one started, I didn't say this, but if it was the year 2015 when I took this information down, there's 1,450 students. The population in 2020, now do I put a year 2020 up here? No. Okay, t is how much time has gone by. Well, how much time has gone by from 2015 to 2020? That would be 5 years. So I would replace this with a 5. Okay. And then I would go back to my calculator. If I type it in up there again, 1450 times 1 plus 0.025 raised to the 5th power. And in the year 2020, there would be approximately 1,640, technically 0.5 students. You really can't have half a student, so I guess we would round down to 1,640 students. Okay. And yep, I should probably label that if possible. Okay. But that's the exponential growth one. And again, we're going to see another one in a minute here, but the population increases, so we're going to add that percentage on. Okay, so it's not too bad. Okay, again, how about if I set up this one real quick, like just the equation. The beginning amount was $7,890. We're increasing by 1.6%. So, whoops, 1 plus 0.016 raised to the t power is what that equation would look like. Okay. And to answer the second part down here, if it was the year 2000 when I started, the year 2023 is 23 years later. I'd plug in a 23 for the t. Okay. Again, if I go back to my calculator real quick, I'll take the 7890, 1 plus 0.016 raised to the 23rd power. The college tuition would be about $11,366. And if I go 2 decimal places, it's going to stay 64 cents. So it's a pretty user-friendly equation, pretty user-friendly formula. Okay. All right, next off, we're going to look at exponential decay. And if you can read that or not, but it's very, very, very similar. It's exactly the same equation as exponential growth. The only difference is there's a minus sign here in the middle. Okay, and I'm going to write that one over here also for exponential decay. So y equals a times 1 minus r to the t power. Okay, and all the parts stand for the exact same thing. A is the original amount. Okay. The r is the rate, the percent. T is time. But instead of increasing by a certain percentage, it's going to decrease by a certain percentage. So that's why it's subtraction. Okay, can we try taking a look at one of these? Okay, a $30,000 car. It depreciates at 12% per year. What will the value of the car be in 5 years? Well, can we write an equation? A, the original amount, is $30,000 times 1 minus, it's decreasing. And if I change my percent into a decimal by moving it 2 places over, 0.12 to the t power. How much will it be worth in 5 years? Well, we're going to replace the t with a 5. Okay, and one more time, I'll grab my calculator. And we'll go $30,000 times 1 minus 0.12 raised to the 5th power. It would be worth $15,831. If you look closely up there, the 7 is going to make the 5 turn into a 6, so 96 cents. Okay. There's exponential decay, decreasing with the subtraction sign. Okay. All right, this one's a little bit, similar. It says you want to save money to buy a car. The car costs $8,000, and you know that if you put money into the bank right now, you'll earn 3.25%. You plan to save your money for 5 years. How much do you initially have to invest? Ooh. So we're looking for this. How much do you initially want to invest? Okay, it's going to increase, so it's going to be plus r to the t power. Okay, so the question is, what part of that equation are we trying to find? This time, we're not trying to find the ending amount. The ending amount is the 8,000 that we want to end up with. This initial amount is the a. That's what we're trying to find in this problem. Okay, so if I plug in my numbers, plug in some numbers into this formula, it's going to be 8,000 equals a times 1 plus 0.0325 raised to the 5th power. Okay, so we're going to try and find the a now. Okay, now, that looks kind of confusing here. How are we going to find a? Okay, well, what if I did all this stuff and got a number? So I got 8,000 equals a times something. Can we find the value of that on my calculator? 1 plus 0.0325 all raised to the 5th power. Okay, so that's approximately 1.173. We can round off a little bit. Okay, and then to solve for a, it's just a little algebra problem. If I want to get a all by itself, here's a. It's being times by that. We're going to divide by 0.173. They cancel. And that's going to tell me how much I should initially invest. Okay, if I take 8,000, let me clear out here again. 8,000 divided by 1.173 tells me I should initially invest $6,820.12. $6,820.12. Now think about that for a second. If that's what I start with, and it's going to go up by 3.25% each year, the money should grow. Yep, it should have started with less than $8,000. Okay. All right, so that was a little bit different in that we were trying to find the value of the letter A. Okay. Hopefully we're doing okay so far. Okay, last thing. This is the very last thing we're going to talk about. It's kind of an extension of this exponential growth formula. It's called compound interest. Okay, and you guys know a little bit about something with interest. Interest is when you put money into the bank. Okay, many of you guys have savings accounts and things, but interest is where the bank pays you a little bit of money for you keeping your money at their bank. Okay, they give you a little bit of interest, a little percentage. Okay, well, there's this compound interest formula. It looks like this: A times 1 plus r over n raised to the n times t power. That might be worth writing down somewhere. Okay, it looks very similar to this exponential growth problem. Okay, many of the parts have the same definition or the same meanings. This is the ending amount. A is your starting amount again. Okay. R is your percent. And don't forget, it has to be changed into a decimal. Okay. T is time. But the new pieces there is this letter N. What in the world does N stand for? Both of these N's stand for the same thing. Okay? It's the number of times something is compounded per year. Okay? So it's kind of basically what that means is the number of times a year they kind of recalculate things. Okay? Yeah. There's some key words here that go with this. Okay? If something is compounded annually. How many times a year is annually? This again is something worth writing down. Annually is one time a year, each year. Okay? Big businesses operate on quarters. Well, our school operates on quarters actually, but maybe you've heard of a big business having like a third quarter profit or a fourth quarter loss. Okay? But quarter, just like you probably think, means four. It'd be 4 times per year. 4 quarters in a dollar, 4 quarters in a football game, and so on. Okay? Sometimes things are compounded monthly. How many times a year is that? Well, yes, there are 12 months in a year. Okay? Weekly, I don't know if we see this or not, but maybe you know, maybe you don't know. How many weeks are there in a year? There are 52 weeks in a year. Okay, those are the most common ones that you're going to see. Annually, quarterly, monthly, and weekly. Okay, and I'm just going to rewrite this equation right over here so I have it one more time. Plus r over n raised to the n times t power. Okay? Okay. Oh yeah, there might be one other one. That's called semi-annually. Okay. Well, do you guys know what the prefix semi means? Like a semicircle? It's half a circle, meaning 2 parts. So semi-annually would mean 2 times per year. That's another one that you might see also. You're right. Okay. All right, but here's this formula. Here's this equation. Let's see if we can answer a compound interest problem. Okay. Oh, and by the way, this page is also in your book. Okay. If it's a little clearer, a little better to copy out of there, you certainly can. Okay. That talks about compound interest. Okay. Let's take a look at one of these. Okay. Maria's parents invest $14,000, 6% compounded monthly. How much money is in there after 10 years? Well, let's try it. Okay. A, if I look over there, A is the beginning amount. The amount we're starting with is $14,000. 1 plus R, the rate, 6%. We've got to change it to 0.06 divided by n. Now here's the key. What is n? Does it tell us how many times it's compounded per year? It says monthly. That means n is going to be 12. 12 times per year, raised to the 12 times 10 power, 10 years later. So there's the equation with all the numbers in it. Very similar to exponential growth, but now we have that n in there. One thing I like to do first before we get the calculator out, I think it's a good idea to do this multiplication. Okay? 12 times 10 is 120. Okay? So we're going to do all that stuff and raise it to the 120th power. Now when you grab your calculator and you type this in, we have to be a little careful again how we do that. Okay, I'm going to type in 14,000. You can pretty much type in exactly what we read. 1 plus 0.06 divided by 12. We don't need another fraction in there because it's inside, or parentheses in there because it's already in the parentheses. And it's going to do that division first. All raised to the 120th power. Okay. How much money will be in her account? Well, after 10 years, 120 years? No, I'm sorry, after 10 years, she's going to have $25,471.55. So she almost doubled her money. Doubling her money would be $28,000. Almost doubled it in 10 years. Okay. But there's that little equation called compound interest. Okay, let's try one last one here. Last one. Maybe let's see if you can take a minute and try this one by yourself. Okay, go ahead and push pause on the video. And when you're ready, go ahead. And when you're done, press unpause, and we'll go through it together. Ready, set, go. Okay, welcome back. Let's give it a whirl. If I plug in my numbers into my formula, A, the initial amount, she's going to invest $300 at 3.5%, so 0.035 over n, and And this time it's quarterly, so n is 4. And it's raised to the 4 times 22. Okay. And like I said before, I like to do this multiplication. 4 times 22 is 88, so let's raise it to the 88th power. Okay. So there's our equation with the numbers in it. Now it's just a calculator problem. Let's type in 300, 1 plus 0.035, divided by 4, because it's quarterly, all raised to the 88th power. Okay, and after 22 years, it's going to have $645.76. $645.76. Okay. Yeah. Okay. So there we have it. A little bit of exponential growth, a little bit of exponential decay, and a new formula for you this time called the compound interest formula. Okay. Lastly, I guess in closing, if you have any other questions, certainly look at the examples in your book. They do a good job of it there too. All right, thanks for tuning in.